All right, I'm going to share the solution to our transshipment problem in Excel. And I've gone ahead and I've just organized this spreadsheet. You can organize it however you wish. Many different ways to organize this. But you'll see, of course, here are the costs in dollars per ton for shipping out of Nebraska and Colorado and into Kansas City, Omaha, and Des Moines, and then shipping out of Kansas City, Omaha, and Des Moines, and shipping into Chicago, St. Louis, in Cincinnati. So these are our costs. Again, all I did was copy and paste these cells. All I copied and pasted these cells into these cells, made a few changes as you'll see, but just emptied out the cells. And again, these all represent the respective 15 decision variables. There's 6 decision variables here and 9 decision variables here. Again, the decision variable this cell represents is in K, this is in O, and this is in D. So even though these cells stay empty, those that are the decision variables they represent. Now, in order to complete the formulation, the first thing that I did was to calculate the value of the objective function. And the objective function I've shown here is the sum of 2 sum products. It's the sum product of this group of cells with this group of cells plus the sum product of this group of cells with this group of cells. And so this sum product function that's I'm highlighting here is the function that's in the objective function cell. Then in order to organize in these 2 cells, I'm going to respectively calculate the total amount of potatoes by adding up these 3 cells, the total amount of potatoes that are leaving Nebraska. So this then is the sum of the values of these 3 cells. Those are the potatoes that are leaving Nebraska, and they have to be less than or equal to 300 tons. And similarly, this group of cells is the sum of these 3 cells, and that gives the total amount of potatoes out of Colorado. Now, in these 3 cells, I'm going to calculate the sum of the potatoes from these 2 cells, which are the potatoes that are going into Kansas City. Again, this would be NK and this would be CK. And if you look back at the diagram, the sum of those 2 values would be the potatoes going into Kansas City. And then similarly, this would be the case for Omaha and Des Moines. So this cell represents the total amount of potatoes going into Omaha. This cell represents the total amount of potatoes going into Des Moines. So, and then for the next table, I'm going to do exactly a similar thing. I'm going to calculate the number of potatoes that are leaving Kansas City and the number of potatoes that are leaving Omaha, and then in that cell the number of potatoes that are leaving Des Moines. And then again, right below, I'm going to calculate the number of potatoes that are coming into Chicago. And as I drag that over, the number of potatoes that are coming into St. Louis, and finally the number of potatoes that are coming into Cincinnati from those 3 cells. All right, and again, these potatoes in from Chicago, St. Louis, Cincinnati have to be greater than or equal to the demand. All right, so these will be used as our supply constraints. These cells will be our demand constraints, and so then we have to figure out how do we do our balance constraints. And there's several ways to do this. But what I'm going to do is I'm going to say that enter the constraint, the potatoes into Kansas City. This cell is going to be strictly equal to the potatoes that go out of Kansas City, which is this cell. So that's what's going to appear as a constraint in the solver table. So now we've got everything here that we need to solve. So we're ready to solve. I'm going to go to the data table, go to solver, and of course I know this doesn't show up, but I'm going to take a picture or take a screenshot of this solver window and show you exactly what it looks like. Okay, so first thing is we want to highlight our objective function, which is being highlighted, but it's this cell. And then our changing variable cells is going to be a group of cells. So we're going to highlight, and of course in this case we want to select the minimization. This is a minimization problem. Don't forget to select that radio button. Otherwise it'll be may get an answer that doesn't make any sense. And so the changing variable cells, we're going to highlight. For our changing variable cells, this group of cells, enter a comma, and then highlight this group of cells, and that becomes our changing variable cells. Okay, then we're ready to enter our constraints. The first constraint group is going to be, I'll hit the add button. The first constraint group is going to be these potatoes out of Nebraska and Colorado have to be less than or equal to these constraint values. I didn't pick that up correctly. The potatoes out have to be less than or equal to the limit. And then we want to add the demand constraints. The potatoes in to Chicago, St. Louis, and Cincinnati have to be greater than or equal to our demand. And then I'm going to add the potatoes going into Kansas City have to be strictly equal to the potatoes going out of Kansas City. The potatoes into Omaha have to be strictly equal to the potatoes going out of Omaha. And the last constraint, the potatoes going into Des Moines have to be strictly equal to those that are going out of Des Moines. And that captures our constraints. And then we want to make sure the unconstrained variables are non-negative. Select simplex LP and solve. So the solution is found. And again, we need to figure out how much money that is. Whoops. Which is $12,400. And you'll see that's the cost, that's the minimum cost. 300 potatoes go from Colorado to KC. 300 go from Nebraska to Des Moines. Nothing is going through Omaha. And then from Des Moines, 200 go from Des Moines to Chicago, 100 go to St. Louis, and then 300 go from Kansas City to Cincinnati at a cost of $12,400. Okay, so that's the solution. Again, I would suggest you go in and look at this, make sure you know where it is. Lots of different ways to organize this, but this is how you would solve a transportation problem in Excel. Again, I'm going to take a screenshot of the solver window and put that on the in the PowerPoint slides for you to use. Okay, all right. Hope you can manage this and try to use it to and understand how to use it.